Right, good morning. Welcome to a video of this half term, first one. Hope you all had a nice half term. It's still sunny. And look at that rose. It loves the sun. Anyway, right, so, okay, here we are today looking at rounding, decimal places and significant figures. It does start very easy and then gets by the end quite challenging. So go through and then the work I'll set, do what you can, and then at the end I'll set an extension. Okay, so place value and the value of. So the easiest question they'll ask you is like this. So what is the value of the 7 in 782? Well, it's 70 because you've got units there and tens there, so that's 7 tens, which is 70. The value of the 2 in here. Now you can, if you want, put a little with your units, tens, hundreds, thousands. So value of 2, that's 2 hundredths, which is 200. The value of the 2 here, when it's in the units column, that's 2 units. And the value of the 2 here, it's in the tenths column, so units, tenths. So that's 2 tenths, 2 over 10, which is 0.2. And the value here would be 2 in the thousandths column, which is 0.002 or 2 over 1,000. Okay, so that's the easiest they'll ask you. They then will say, what about rounding? Round to the nearest 10, 100 or whatever. So if we want to round to the nearest 10, you just get, so you're rounding to the nearest 10, so you look at the unit. So the unit is 6, that's 5 or more. So this number's closer to 880. So essentially you're just thinking, look, is it 870? Do I leave it as it is? Or is it 880? Okay? And you round it up because that last digit is 5 or more. Here, it's not, so you round it down. So that number's actually closer to 870 to the nearest 10. That's closer to 880 to the nearest 10. Okay, this one here. Again, don't worry about the 0.9 or anything. You round into the nearest 10, so you look next to it. That's less than 5, so you leave it as 870. That number is closer to 870. Okay, what about to the nearest 10 here? 6, well, you'd have to round it up to the nearest 10. Again, up to the nearest 10. Here is less than 5, so you round it down. So to nearest 10 is 0. This is silly rounding. They'd never ask you to do this because in real life it's just so rounded it just wouldn't be useful in a calculation. Okay, round to the nearest 100. So before you'd look at the units column to round the tenths. Now you're looking at the tenths column to round to the hundredths. So what you would do here is say, well, this is more than 5, so this needs to add 1, so it's actually 900. So this number is closer to 900 than it is to 800. This one, again, you round into nearest hundreds, so you look at the tenths. That's less than 5, so you leave it as it is, 800. Here, looking at this one, because you're rounding to nearest 100, you look at the tenths. That's greater than 5, so you add 1 to that, which is 0 plus 1 is 1, making it 100. Okay, so that to the nearest 100 would round down to 0. This to the nearest 100. Look at the tenths. That's 5 or more, so you add 1 to it, it's 3,300. And this one here, even though you've got these lovely 9s, is still going to be 400 because you're rounding to the nearest nearest 100. So you look at the tenth, which is less than 5. So that's why it's 400. Okay. So another way of rounding is decimal places, and again you're using the same method for all these rounding. You look at the place after, and if it's more than 5 you go up 1, if it's less than 5 you leave it as it is. So if we want 3.25 to 1 decimal place, so we're only allowed 1 place after the decimal, so we look at the 5, the one next to it. If it's 5 or more we add 1. 3.3. Here 3.24, we want 1 decimal place, we look at the second decimal place, it's less than 5, so we leave it as it is, 3.2. Here we want 1 decimal place, so you look at the second, it's greater than 5, so you add 1, 89.1. And here you want 1 decimal place, you look at the second, it's greater than 5, so you add 1, Now adding 1 to that 9 makes it 10, so you carry that 1 across there, making the whole thing 4. And here, don't worry about the last 9, you want 1 decimal place, so you just look at this 9, second decimal, and it's 5 or more, so you add 1 to that, making it again 4. Okay? Even though it's a 0, it's asked you to 1 decimal place, so you must write 1 place after the decimal. Okay, what about 2 decimal places? Well, you want 2 decimal places. Okay, so you're going to be then looking at this one here, looking at the third. So that's 5 or more, so you add 1 to that, making it 8.63. 2 decimal places. So you need to look at this one, the third decimal, which is less than 5, so you leave it as 8.62. This one, third decimal, because you want 2 decimal places, is less than 5, so you leave it as it is, 8.60. This one is greater than 5, so you add 1 to that, meaning it ends in 10. Adding 1 to that, meaning that's 10, and the whole thing ends up rounding to 9. And again, you've got to put 0.00 because you're writing 2 decimal places. And this one here, 2 decimal places, looking at this, is less than 5, so you leave it as 8.99. Okay, so decimal places you use to round when you're rounding decimals. Significant figures are what you use to round when you're rounding larger numbers. You can use them for decimal places, but generally used for larger numbers. Okay, so it's up to the amount of non-zero digits unless the 0 is in between them. Okay, so if I said, like, write this number to 1 significant figure, you're only allowed 1 non-zero digit to get as close to that as possible. So your only options are 30,000 or 40,000. That's far closer to 30,000. There you go. If you wanted 2 significant figures, you're allowed 2 non-zero digits. So, effectively, 33,000. Because it's closer to 33,000 than 32. So if you think of it like with your decimal places. So, 1 significant figure here. Have a look at that. That's less than 5, so you leave it as it is. 30,000. 2 significant figures here and here. Next one along is 5, so you round that up, 33,000. 3 significant figures, you got these 3. Next one along is greater than 5, so you add 1, leaving it 3, 2, 6. Okay? Then you add in the rest of the zeros, because obviously otherwise the number wouldn't be close to it. So similarly, 4 significant figures, you leave the 8 as it is, because that's less than 5, so it will just be this with 1 0 on the end. 4 significant figures, 1, 2, 3, 4. Okay, so similar here, you've just got 35,994, 1 significant figure. Look at the 3, that one there is 5 or greater, so you add 1 to it, meaning it's 40,000. To 2 significant figures, 2 non-zero numbers. That's greater than 5, so you add 1 to it, meaning 36,000. So notice, the more significant figures you're allowed, the more accurate, the closer to the original number you can get. To 5 significant figures, this is simply 35994. Okay, a couple more examples. So this one here, 20,790, 1 significant figure. Well, that's 4 or less, so you just leave the 2 as it is, 20,000. 2. This one here is greater than 5, so you're going to add 1 here, meaning 21,000. 3 significant figures, 1, 2, 3, so you look at the 4th. That's greater than 5, so you add 1 to that, meaning 20,800. And 4 significant figures, 1, 2, 3, 4. Well, you don't do anything with that 9, because this number here is less than 5, so you just leave that as it is. Now luckily that is actually 4 significant figures as well, because you've also got that 0 in, so that counts. Okay, the 0 here counts as well, so this is 3 significant figures. Right, what about 9,999? What are we going to do with that? Well, 1 significant figure, you're looking here, and this one, the one next to it, is greater than 5. So you add 1 to this, meaning it becomes 10. So you've got 10,000. Two significant figures. You look at a third, well that's greater than 5, so you add 1 to that, meaning it becomes 10. Adding 1 across to that, meaning that becomes 10, and it's still 10,000. Three significant figures. Look at that one. Add 1, add 1, add 1 across. So those three are all, even though they're all actually only written to one significant figures, remember what we said up here is up to. If you can get your number written to less significant figures than it asks and still retain the accuracy, that's absolutely fine. Okay, and 10,000 is only 1 away from 9,999. And 4 significant figures, obviously, you don't do anything with it. It's all 4, there's nothing to change. Right, so that's decimal places, significant figures and rounding. If you wish to go up a huge jump in levels, there is something called error bounds, which I thought I'd add as an extension. So it's up to you if you wanted to do this. But it is quite nice, okay? And it's only for the brave. Right, okay, so it gives you the answer and then it asks you what the lowest and the highest could have actually been before it was rounded. So if the answer is 4 and it was rounded to one significant figure, then what could it have been? What's the lowest number that would still round up to 4? Well, 3.8 would easily, 3.7, 3.6. 3.5 has got to be the lowest number that would still round up to 4. So 3.5. What about the largest number that would round down to 4? We've got 4.1 word, 4.2, 4.4. 4.49 is actually larger, and that would still round down to 4. What about 4.4999? What about 4.49999999? So 4.49 reoccurring is actually the largest. Now there is a weird mathematical proof where you can prove that 0.49 reoccurring is the same as 0.5. So you can technically write it as 0.5, even though really 4.5 will round up to 5. So it's a little bit confusing. Okay, so with 4, the lowest is 3.5 and the highest is kind of 4.5. Really, it's 4.49 reoccurring. Now, all you've really done is said you're rounding to one significant figure and it's a unit. So you get that unit and split it into half and take it away and add it on. So that one unit goes half either side. 7, lowest you could have been is 6.5. Highest, still round down to 7, would be 7.49 reoccurring, which we're just going to write as 7.5. 15, half below it 14.5, half above it 15.5. What about when you've got bigger numbers? Oh, 82, still the lowest is going to be 81.5 and still the highest is going to be 82.5, which is really 82.49 reoccurring. Okay, 73 would be here. Okay, so each time you're just getting the unit and you're splitting it. Well, what if it was two significant figures? What if your answer was 80? What's the lowest two significant figure number that would round up to 80? Well, 75 would work, wouldn't it? That's the lowest number that when rounded to two significant figures will give you 80. Okay, and here, so 75 and the highest here 84.9 reoccurring, which is 85. So you're now getting, it's rounded to the nearest, and shouldn't really be two significant figures, should really be to the nearest 10, to be honest. Anyway, but you're getting the idea. As we've gone up a unit, now we're saying it's rounded to the nearest 10, we'll get half of that either side. To the nearest 10, half either side. To the nearest 10, half either side. Okay? Right, so those are error bounds. We've covered quite a lot today, so well done for listening and goodbye.